Hello everyone, you should have your notes packet out and be looking at the giraffe problem. So the giraffe problem, I'm going to give you an example of how to solve and how to set up a normal distribution problem involving a normal curve and how to use the empirical rule to help you come up with percentages. So the first question, the first statement, it talks about a giraffe, and it says that it's normally distributed and it has a mean of 204 inches and a standard deviation of 5.5 inches, and it asks you to draw a normal curve. So the first thing you should do on your paper is you should set up and you should draw a normal curve. And the normal curve should look something like this. And down the middle you have the mean, which was 204. And then you would count 2 to the left, 1 unit to the left, and that would be 5.5 inches. So 204 plus 5.5, you get 209.5. Then you go another little bit out and you put another 5.5. And then you do the same thing to the left. And then inside, using the empirical rule, which you talked about in the video last night, within one standard deviation of the mean is 68%. So if you go one standard deviation to the left and one standard deviation to the right, the way I did here, one to the left, one to the right, each of those is 34%. Two standard deviations out is 95%. So from here all the way over to there is 95%. So if we know this one's 68, these two add up to 68, that means this one and this one have to be equal and they have to be 13.5. And then finally, 3 standard deviations out, the last little piece is the other 5%. So that means this number and this number is 2.5%. Once you've drawn your normal curve and you have everything labeled, the way we write this statistically is we would say that x is a random variable. It has a normal distribution with a mean of 204 inches and a standard deviation of 5.5 inches. You always want to get in the habit, anytime you're doing a normal distribution problem, that you label it this way. This is the statistical way you write this. And then you also want to label out, you want to draw out the curve. It's going to be very important. Before the end of this year, you are going to be drawing thousands of these curves. So it's going to be very important to get the hang of it very quickly. A very typical question would ask you like this: what percent of the giraffes are taller than 215 inches? So if we use our curve, you can see we have 215 labeled, and then you can just count the different numbers, the different percentages between there. So to answer this question, the way you would write this is you would say that the probability that x is greater than 215 is equal, and then you just add up the percentages in the middle to get your answer. And you can see that your answer is 2.5%, the probability that they're taller than 215. These would be the very tallest of all the giraffes. The next question, what percent of the giraffes are shorter than 204? So again, we go back to our curve and we figure out where 204 is, and then we would count up the red percentages to see what percentage of them are taller than 204. And the way you would write this, statistically you would say the probability that x is less than 204, and we add up all of those numbers, all of those red percentages, and you can see that it adds up to 50%. Right? 204 was the halfway point. Half of them are bigger, half of them are smaller. What percent of the giraffes are taller than 198.5 inches? Back to our chart, you can see how important this curve is. This is very important. You have to be able to refer back to this. So we look back at this and we see where's the 198.5. And then we would count. We're interested in all the ones that are taller. So we would add up all the percentages that are taller than 198.5. And so you can see I did that on this one. Probability that x is greater than 198.5. And you can see I added up all the reds. So 34 and 34, 13.5, and 13 and 2.5. And that all adds up to 84%. Right? You don't have to show all those adding, but that's the process that you're going to use to do this. Now, the last problem, problem number 4, is very similar. It's just slightly worded differently. Remember, when you are trying to find a percentile, you're trying to find what percent of the giraffes are less than or equal to the number we're being asked for. So we're being asked to find what percent, or a height of 209.5 corresponds to what percentile. So if you go back to our chart and we find 209.5, if we're trying to find a percentile, we're trying to find the percentage of the giraffes that are smaller than 209.5. So you can see by looking at your chart which one of those numbers that is. And then you would write that this way, the probability that x is less than 209.5, and we would add up those numbers, and once again we get 84%. So this is the way you're going to approach these types of problems. So now you should be ready to answer some of your own questions based on this same technique.